this episode, we're going to zoom in on 3 practices that make artifact management trustworthy instead of fragile: versioning, the use of external repositories, and software bill of materials, SBOM, habits. When software moves through automated delivery, artifacts become the units of truth, meaning deployments are really deployments of specific artifact versions. If you cannot tell which version is which, if you cannot trust where an artifact came from, or if you cannot explain what is inside the artifact, you will eventually lose control of reliability and security. Versioning gives artifacts stable identities over time. External repositories give you controlled places to obtain dependencies without pulling from random locations. SBOM practices give you a clear inventory of components so you can assess risk, respond to vulnerabilities, and meet auditing expectations. These ideas are not just paperwork. They are operational tools that reduce confusion during incidents and reduce surprise during security events. For beginners, the goal is to understand what each practice accomplishes and why they fit together. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Start with versioning, because it is the simplest idea with the biggest impact. Versioning is the practice of assigning a clear, structured identifier to a specific artifact so that humans and automation can refer to it unambiguously. In an operational environment, versioning is not about looking professional. It is about making rollouts and rollbacks deterministic. If you deploy version 2.4.1 today and it fails, you want to roll back to version 2.4.0 and know you are truly getting the prior bits. If version labels are sloppy or reused, you lose that certainty, and every deployment becomes a gamble. Good versioning also supports communication, because teams can discuss issues using a shared identifier rather than vague phrases like the latest build. For a beginner, the important shift is to treat version numbers as part of the safety system. They are not a decoration. They are how you keep track of what is running and what changed. Versioning also helps you reason about compatibility and risk in a way that is valuable even when you are new. A well-structured versioning approach can signal whether a change is likely to be a breaking change, a feature addition, or a small fix, which helps operators anticipate what could go wrong. It also supports staged rollouts, where you gradually move from one version to the next and compare behavior. Another operational benefit is that versioning makes it easier to correlate artifacts with source changes, tests, and approvals. When a build produces an artifact, that artifact should have a version that can be traced back to a specific build run and a specific code state. That traceability is crucial during incident response, because the first question is often which change introduced the problem. If you have clean versioning, you can answer that quickly and accurately. Clean answers reduce downtime because they reduce debate. Now connect versioning to the idea of immutability, because versioning only helps if the version refers to a fixed artifact. If version 1.0.3 can be overwritten, then the label no longer means anything trustworthy. Operators therefore treat version identifiers as immutable references, meaning that once a version is released, it always points to the same content. In many systems, this is reinforced by using content digests, which are derived from the bits themselves and therefore change when the artifact changes. Beginners do not need to know the math behind digests to understand the concept. It is like a fingerprint of the artifact. If the fingerprint matches, you have the same artifact, and if it does not, something changed. Versioning plus immutability gives you both a human-friendly label and a machine-verifiable identity. That combination is what makes rollbacks and audits reliable. Without it, version numbers become wishful thinking. External repositories are the next piece, and they matter because most artifacts are built from other components. An application rarely stands alone. It depends on libraries, base images, and other packages. An external repository is a managed source for those dependencies, often provided by a vendor or a trusted third party, and it allows you to obtain components consistently. The key word is consistently, because pulling dependencies from random internet locations creates unpredictable builds and introduces supply chain risk. External repositories can provide signed packages, consistent metadata, and reliable availability, which helps both security and uptime. Operators also use internal mirrors or curated repositories, which are still external to the application project but are controlled by the organization to enforce policy. This helps ensure builds do not unexpectedly change due to a dependency publisher updating content behind the scenes. For a beginner, the core idea is that where you get dependencies is a security decision and a reliability decision. External repositories also change how you handle updates and vulnerabilities because they become a control point for what versions are allowed. If you rely on uncontrolled sources, you might accidentally pull a new dependency version that breaks your build or introduces unexpected behavior. If you rely on a controlled repository, you can decide when to update dependencies and test them before they enter production pipelines. This is especially important for reproducibility, which means being able to rebuild the same artifact later and get the same outcome. Reproducibility matters for debugging and for compliance, because if you cannot reproduce an artifact, you cannot confidently analyze what was deployed. Operators care about this because long after a release, you might need to investigate a security issue or rebuild a patch quickly. External repositories, when managed carefully, help keep builds stable and repeatable. Stability is not the enemy of speed. It is what keeps speed from turning into chaos. Now bring in SBOM practices, which are about visibility into what an artifact contains. A software bill of materials, SBOM, is an inventory of components included in a piece of software, such as libraries, dependencies, and sometimes even transitive dependencies, which are the dependencies of your dependencies. The value of an SBOM is that it helps you answer questions that otherwise take days during a security event. If a new vulnerability is announced in a widely used library, you want to know quickly whether your artifact includes that library and which versions are affected. Without an SBOM, teams scramble to search code, inspect build logs, or guess based on memory, and those approaches are slow and error-prone. With an SBOM, you have a structured list that can be checked systematically. For beginners, the important point is that SBOM practices turn unknown contents into known contents. Known contents are manageable, unknown contents are risk. SBOM practices also improve operational communication because they give you a shared language for what is inside a release. Instead of saying the application uses some open-source dependencies, you can say exactly which ones and which versions. That helps with auditing and helps with customer trust. But it also helps internally when teams need to coordinate updates. It also supports incident containment because you can identify which services are affected and prioritize patches based on exposure. Another subtle benefit is that SBOM information can help you detect unexpected components, which can signal compromise or build misconfiguration. If an artifact suddenly includes a component that was not there before, that change deserves investigation. That is not paranoia. It is a normal part of maintaining a stable supply chain. Operators treat the SBOM as a baseline, and deviations from the baseline become clues. Versioning and SBOM practices reinforce each other because a version without an inventory is still a black box. If you deploy version 3.2.0, you should be able to say what changed, and part of what changed might be dependency updates rather than application code. The SBOM helps you explain those changes, and versioning helps you tie those changes to a specific release. This also matters for rollback decisions. If a vulnerability is discovered in a dependency, you might roll back to a version that used an earlier dependency version, or you might need to patch forward. Without versioning, you cannot target a known good state. Without an SBOM, you cannot know whether the known good state is actually free of the vulnerable component. Operators do not want to guess in these situations because guessing can lead to deploying a version that is still vulnerable or that breaks compatibility. The combination of versioning plus SBOM replaces guesswork with evidence. External repositories connect here as well because they influence what ends up in the SBOM and how stable those components are over time. If dependencies come from controlled repositories, the versions and metadata are more consistent, and the SBOM is more trustworthy. If dependencies come from uncontrolled sources, you may see surprising drift, where the same build process produces different dependency sets at different times. That drift makes SBOM less reliable and makes incident response harder. Operators therefore care about controlling sources so that the inventory remains stable and explainable. They also care about aligning repository policies with versioning policies so that you do not accidentally ingest unreviewed versions. Again, this is not about adding bureaucracy. It is about making change predictable. Predictable change is what allows automation to move quickly without breaking trust. There are common misconceptions that can undermine these practices if you are not careful. One misconception is that version numbers are only for external customers, when in reality they are even more important internally for traceability and rollback. Another misconception is that using an external repository automatically means you are safe, but safety depends on whether the repository is trusted, monitored, and used consistently. Another misconception is that an SBOM is only for compliance, when operationally it is an emergency map that saves time during vulnerability events. A final misconception is that these practices slow you down, when in reality they reduce wasted time caused by confusion, rework, and emergency fire drills. Operators measure speed by how quickly you can move safely, not by how quickly you can push a change and hope. When your artifact story is clear, speed increases because troubleshooting and decision-making become faster. To wrap up, applying versioning, external repository discipline, and SBOM practices to artifacts is about turning artifacts into trustworthy, traceable units that you can manage over time. Versioning gives each artifact a clear identity that supports release coordination and reliable rollback. Controlled external repositories provide consistent, policy-aligned sources for dependencies so builds are reproducible and supply chain risk is reduced. SBOM practices give you visibility into what each artifact contains, which is essential for vulnerability response, auditing, and detecting unexpected changes. Together, these practices reduce both operational risk and security risk because they limit surprise and increase evidence. When something goes wrong, you can answer the key questions quickly. Which version is running? Where did it come from? And what is inside it? That ability is what separates mature automation from chaotic automation, and it is exactly the kind of operational thinking this certification wants you to develop.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.